Chapter 1, Section 7, the midpoint and the distance formula, now in the coordinate plane. So rather than a number line, we're going to be working on a coordinate plane. First, finding the midpoint. Well, let's say you're given two sets of points, x1, y1, and x2, y2. In order to find the midpoint, you're going to do x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So in the example we have here on the right, x1, y1 would be 1, 1, and x2, y2 would be 4, 5. It doesn't matter which one you label as x1, y1, or x2, y2, but one of them is the first set of points and one of them is the second. Well, here we would just do 1 plus 4 divided by 2 and 1 plus 5 divided by 2. So 5 divided by 2 gives us 2.5, and 6 divided by 2 gives us 3. So we go over about 2.5 and up 3, so you can see that our midpoint is approximately here. Now finding the distance, there's two ways that we can find the distance. The first way that we can find the distance of this line segment, so let's say AB, by making this into a right triangle, we'll be able to use the Pythagorean theorem, which says a squared plus b squared equals c squared. So this is our A, B, and the hypotenuse is C. When it's a horizontal or a vertical line, in order to find the length, you can just count. So the bottom is 3 units. The right-hand side is 4. So we're going to do 3 squared plus 4 squared equals c squared, which means 9 plus 16 equals c squared. 25 equals c squared. Take the square root of both sides, which means c equals 5 units. So this is one way to find distance, but there is a distance formula that you will need to know. So the distance formula states that the square root of x2 minus x1 squared plus y2 minus y1 squared should get us the same answer that we got before, which was 5. So plugging in our numbers, again, let's make 1, 1 our x1, y1, and 4, 5 our x2, y2. So we'd get d equals the square root of 4 minus 1 squared plus 5 minus 1 squared. So that gives us the square root. 4 minus 1 is 3, 3 squared is 9, 5 minus 1 is 4, 4 squared is 16. So that gives us the square root of 25, which again is 5 units. Either method is okay to use, but sometimes you're not given the graph, so you have to use the distance formula. And sometimes, like when we're proving, which we will in the future, you have to use the distance formula. Take a minute to find the midpoint of AB, which you're going to label as M, and the distance of AB using both the Pythagorean theorem, so making a right triangle, as well as the distance formula. The distance formula is something that you're going to have memorized. So pause the video and then unpause it once you're complete. So, in order to find the midpoint, we have to first find the average of the x-coordinates and then the average of the y-coordinates. So, if A has x1, y1, and B has x2, y2, we would do -3 plus 5 over 2 and +4 plus -4 over 2. -3 plus 5 gives you 2, divided by 2 gives you 1. 4 plus -4 is 0, divided by 2 is 0. So point M would be at 1, 0, which is right here. Now, in order to find the distance, by making a right triangle, this is one way which we can find the distance. So you can see the bottom side is 1, 2, 3, 4, 5, 6, 7, 8 boxes long. The left-hand side, 1, 2, 3, 4, 5, 6, 7, 8 as well. 8 squared plus 8 squared equals c squared. 64 plus 64 equals c squared. 128 equals c squared. Then we take the square root of both sides. Now you'll notice that when you plug this into your calculator, you do not get a perfect square. Rather than rounding, we're going to simplify the radical. So we're going to break it apart into 2 radicals, one of which is a perfect square. So, I mean, even looking up here, we can see that there's 2 64s. So 2 and 64. 64 is a perfect square, so you get +8 radical 2 units. Now let's try using the distance formula. So x1 is 5 minus a -3 means +3 squared plus -4 minus 4 squared. So this gives us 5 plus 3 is 8. 8 squared is 64. -4 minus 4 is -8. -8 squared is +64. Again, we get the square root of 128, which we know simplifies down to 8 square root of 2. So 8 radical 2 units. The midpoint of AB, line segment AB, is M, which is -1, 5. One endpoint is A, which is -7, 12. What are the coordinates of the other endpoints? So if you think about a line segment, we have AB and M is here. In order to find the midpoint, we would find the x-coordinate by doing x1 plus x2 divided by 2. And that's going to give us, let's say, xm, the midpoint. To find y, we would do y1 plus y2 divided by 2. And again, that would give us the y coordinate of the midpoint. So we know that, let's say, x1 and y1 are -7, 12. So let's plug those in. Well, here, we'll plug in -7, but we don't know what x2 is, but we know when it's divided by 2, we get the midpoint coordinate. So now we're just going to be solving for x2, so we multiply both sides by 2 over 1. cancels here. We're left with negative 7 plus x2 equals negative 2. Add the 7 to both sides, and you get that x2, so the x-coordinate for b, is positive 5. So that's here. Now let's find the y-coordinate. So y1 is 12, plus, we don't know y2, but when it's divided by 2, it gives us the midpoint coordinate for y, which is 5. Again, multiply both sides by 2 over 1. It cancels here. 12 plus y2 equals 10. Subtract 12 from both sides, and you get that y2 equals negative 2, which means the coordinates for M are positive 5, negative 2, as we see here and here.